was running around a forest once, as you do. I think it was in Portugal, and it suddenly occurred to me, a couple of things popped into my head. One of them was this thing I had learnt at school many years before, something like 20 years before. You know, this little equation. So that's your basic photosynthesis equation. A plant takes water, H2O, grabs carbon dioxide. Now where do you get that? It's a gas. Where do you get that? And it produces C6H12O6. And that is like a sugar carbohydrate. Well, it makes the starch. And that is not a byproduct, oxygen. Equation. And I was running around this forest and I suddenly realised something about trees. Now if you look at that, you should be able to know which is the actual basic matter of a tree. Is it hydrogen? Is it oxygen? Or is it carbon? Well, look at it. Huge, solid tree. And the question is, where does this come from? This big, solid thing. The question is, how do we balance this out? Okay, on this side we have 6 carbons, and on this side we've only got the 1. So we need at least 6 on this side. Okay, so we've got 6 on this side, 6 carbons. We need at least 6 on this side. How do we do that? Well, we need 6 carbon dioxides. Okay, but that means that we've got 6 carbons, but we've also got 6 times 2 oxygens, which is 12 oxygens, and that's just for this bit. That's just for this side, this bit. You've also got some oxygens here. Now you've got some oxygens there, you've got 6 for just 1 carbon unit, and you've got some oxygens there. So you've got to balance that out. So I'm not going to go for the oxygens first, I'm going to go for the hydrogens. How many hydrogens do we have? 2 on this side, 12! 12 on that side. In order to equal the 12 on this side, we must multiply this by 6. So we've got 12 hydrogens. Now that means we multiplied this by a bunch of numbers. We've got 6 carbon dioxide molecules, 6 H2O molecules. We've got a total of 12 hydrogens, 6 carbons. How many oxygens do we have? 6 times single oxygens, that's 6, and 6 times 2 is 12, 18 in total. So how many do we have here? Well, we've got 6 carbons, we've got 12 hydrogens, and how many oxygens? We've got 6 there. How many? To balance out the 18 oxygens, how many extra oxygen atoms, molecules do we need? Well, we take away the 6 from there, so that leaves 12, 6. And that's it. And that is our photosynthesis equation. 6 hydrogen, 6 waters, 6 carbon dioxides gives us a total of 1 carbohydrate unit and 6 oxygens. This is our mass. And this, the only bit that's missing from this little equation is the effect of 2 things really. It's the light coming in, that's where the energy comes from, and the important catalyst, which is the stuff that makes effectively the trees green, the leaves green. Chlorophyll. Chlorophyll and energy from the sun somehow or other convert water and carbon dioxide from the air, water from the ground, that's through the roots, getting sucked up through the xylem, and carbon dioxide in the leaves breathing in, and it creates carbon C6H12O6, or effectively a carbohydrate. It makes sugar. And that flows down through the phloem, down to the roots, to nourish the roots and for the roots to grow as well as building up, packing out the whole tree. And as a byproduct, it produces oxygen, which is very good for us. It's made out of wood, it's made out of trees, it's made out of something, mass. And if you're going to go in an exam, this is the kind of thing you want to have in your head, okay? Not only is it about chemicals, about specific bits of elements of basic matter and how it's structured, it also explains in some way where trees come from. And also, because of we're using letters and numbers, it also contains something about balancing from equations. So all these different subjects all wrapped up into one tidy, tasty little equation.